It's your friendly math tutor, Miss C here, and today we are constructing a box and whisker plot from two different data sets. We're starting with this data set that has no context. We're just going to practice the skills. So the first thing we want to do when we are making a box plot is we want to find the values in the 5-number summary. So we want to start by finding the minimum and the maximum. And then between those two values, we find the median, which is the most middle value, the value of quartile 1, which is the median of the lower data, and the value of quartile 3. So I like to start with the min and the max because those are super easy. So this number represents our minimum. It's our smallest value in our data set, and our maximum is right here. So pro tip, if your data is not organized from smallest value to greatest value, you need to reorganize your data because this is not going to be possible to analyze by hand unless you do that. So because my data is already organized from smallest to biggest, I could really easily see my min and my max. Now, we are going to go ahead. Our next thing is we find the median. We can't really find the value of quartile 1 or quartile 3 until we know the median. So what I'm going to do is I'm going to count how many data points I have. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The good news is because this is an odd number, my data point is going to be an exact number in this data set versus the middle point being two numbers that I have to take the average of. So what I am going to do is I am going to count in 5 because since I have 11 points, I know if I count in 5 each way, I am going to come up, and that sixth value will be my median. That happens to be 8. So a quick way to do this, if you have a large data, let's say you have 101 data points, you subtract 1 from 101, you get 100, you divide it by 2. You should have 50 data points on each side. So that 51st value coming from either direction would be your median. Okay, now that we've done that, we're going to do the exact same thing to find quartile 1. So we're going to find quartile 1 in this data set right here. I've got 5 values. I'm looking for the middlemost value, and that is 7. If I count 2 in on this side and 2 in on this side, I land on 7. I'm going to do the same thing here, counting 2 in on this side and 2 in on this side. You are going to notice that I am not using my median value at all when I do this, and that's because that number is exactly in the middle. We're going to look at an example in just a second where we do have to use the two numbers that are used to calculate the median, and I'll explain why then. But for this particular example, because the median is the exact middle and we didn't take an average, we do it like this. All right, and now we're just going to construct our box plots, formerly called a box and whisker plot. I know that I need to go from 3 to 15, so I'm just going to go by ones. I'm using graph paper to be accurate. I'm going to always make a number line, and I'm going to start, I always like to start one less. For time's sake, I'm going by ones, but I'm just going to write every 2. Okay, and then just to be consistent, I'm going to do that. Okay, all right, so here's how I like to do these. I like to plot the median first. So I'm going to draw a vertical line. So the 3 values that have vertical lines are these 3. So start by drawing the median. I'm going to draw quartile 1's value in purple. So I'm going to draw a vertical line at 7 here. And I'm going to draw quartile 3's value in orange just so you can see what I'm doing. And it's at 11, so it's right here. So those are our 3 quartiles. So the second quartile, you could think of the first quartile, you could think of the median as the second quartile, and then the third quartile. So I'm going to go ahead and I'm going to connect these to make a rectangle. All right, and now I'm going to put on my whiskers. Those are the lines that connect our rectangle to our minimums and maximums. So in this case, my minimum is 3. I'm going to put a point here, and then I'm going to just connect it to my rectangle. On this one, my maximum is 15. Put a point on 15 and connect it. What I know about box plots is they divide my data into 4 equal parts, or you could think about quarters. So just like a basketball game is divided into 4 equal parts, we call them quarters. So each quarter represents 1/4 of the basketball game. And in this case, every quarter represents 1/4 of our data set. So I know that a quarter of my values, 25% of my values fall between 3 and 7. Another quarter fall between 7 and 8. Another 25% of my values fall between 8 and 11. And then the final quarter of values fall between 11 and 15. I could also say that where my median is, so my median here is my middle point. Okay. So 50% of the data in my data set falls below the median and 50% falls above. So that's the data that a box plot gives you. Now let's look at why that matters in a real world problem. Here's our real world example. So these are the monthly average high temperatures in the city of Los Angeles as reported by Bing. So we're going to create a box and whisker plot that shows what the distribution of high average monthly temperatures are in LA. So I'm noticing first things first, this goes from January to December. It's the data set I pulled. The data is not in order. So the first thing we want to do is organize our data from smallest to greatest. So I'm going to go ahead and do that. So I'm going to also cross these off. This is the strategy I use because otherwise I can't remember what I've written. And this is my least favorite part about dealing with box and whisker plots. I actually like them a lot, but I hate this part of making them because I always feel like I forget a number, but I didn't this time. And then I have to like erase if I'm doing this on paper. So, okay, so our numbers are in order. So we are going to start by finding our 5-number summary. So our minimum is 67. Our maximum is 89. Okay, right? And this data set is about monthly temperatures. There's 12 months in a year. So I know that if I divide 12 by 2, I'm going to land on the 6th value. So I'm going to count in on 6. 1, 2, 3, 4, 5, 6. So this number and this number we're going to need to use that to calculate our median, which is going to be right here. So the way we do that is we either find the middlemost point, or we take the average. And the good news is you get the exact same number out when you do that. I prefer to find the middlemost point because it's less calculation, but to take the average, you would add these two numbers together and divide by 2, and you would get the middlemost point, also known as 76, right? Because 76 is 2 units from 74, 2 units from 78. We're going to do the same thing to find quartile 1 and quartile 3. I'm noticing that I've got my median's going to be right here. So 3 values on each side. So we take the average of these 2 values or find the middlemost point, and that is 70. On this side, our median would be right here, 3 on each side. Our middle point is going to be 85. Okay, and now what we're going to do is we are going to construct our box plot. I noticed that I'm going from 67 to 89. So that's a span of, I'm going to say I'm going to go by 3s. So I'm actually going to start my graph at 67. I wonder if I have enough room here. It's always the dilemma. I'm actually going by 1.5s, but I'm writing every 3. I always hope I'm going to have enough space. And sometimes it's hard to know if you're going to have enough space, but phew, I did. And I guess technically, since this is a context problem, I'm going to say average monthly high temps in LA. So we're labeling our graph. And now I'm just going to go ahead and plot. And remember, I'm always plotting my quartiles first. So I'm going to go ahead and plot my quartile 1, which is 70. So I'm going to do this. The median is 76. So it's going to be about right here. It's a little crooked of a line. And then the median, the quartile 1 is 85. So that's about right there. And actually, I plotted this one on the wrong side of the line. So it's 76. It should be right here. So now I'm going to go ahead and make my rectangle, and I'm going to do the whiskers. My maximum is 89. So that's going to be about right here. And my minimum is 67. So that's right here. Okay, so this is my box plot. So a lot of times when you are constructing box plots, that's one part of it, but then they want you to analyze it. So I think I'm going to give you 3 things that I would say about this box plot. I am going to say that 50% of the months in Los Angeles have average monthly high temperatures that are less than 76 degrees Fahrenheit, but greater than 67 degrees Fahrenheit. And half of the months in the year in LA have high average monthly temperatures between 76 degrees and 89 degrees. So that's one thing you could say. I would say that in Los Angeles, I'm going to do this part of my graph for my next thing. I would say in Los Angeles, there are 3 months. I'm getting 3 months because remember, each one of these parts of my box and whisker plot, my box plot, represents a quarter of our data. There's 12 months in a year. So this represents a quarter of those months or 3 months. So 3 months in LA have average high monthly temperatures between 85 degrees and 89 degrees. So what we can count on is in 3 months, we're going to see temperatures between 85 and 89 degrees on average. Okay. The other thing that I could say that might be interesting is around the variability. And this is not necessarily like part of the 5-number summary that we call out, but I think part of looking at a box and whisker plot, we look at the variability of data. So how wide is the data spread, right? Is it clumped together in certain quadrants of our box and whisker plot? And is there any sort of skew? And we're not going to talk about those things in this video, but what I'm noticing is I might say something like the range of temperatures of high temperatures on an average monthly basis in LA has a range of, so I'm going from 67 to 89. So if I wanted to find the range, I would do this. I would say this. So I might say something that the range of temperatures in LA on average, when we look at the average monthly high temperatures, is only 22 degrees across all 12 months. There are many other conclusions you could draw from this box plot. If you're really wanting to get meticulous, I think something interesting would be to look at there's a greater spread of data for 6 months because you go from 76 to 89 degrees. You could say something like that. You could talk about the lower quadrant, lots of options. But that's what I have for you today. If you found this video helpful at all, please like it so it shows up for other people. Don't forget to subscribe for more math videos. Until next time, remember, you've got